5G focuses on three key areas. Up until 4G onwards, we basically required more unidimensional skills. But 5G is basically an interesting game shift. Job opportunities and the job responsibilities that they will have to take up, even when they go to more senior level positions, are going to be centered on the basics. A pay scale increased by a minimum of $30,000 to an average of around $50,000.
Hello everyone and welcome back to another episode of Engineering Leaders. Today we have with us Mr. Rajarajan Sivaraj, who is in the forefront of creating various technological solutions for 5G. He has a PhD in computer science with a focus in wireless technology. He has worked with multiple leading research labs across US and UK. Thank you so much for taking the time to give us this interview today. Can you tell us a little bit about yourself, Mr. Rajarajan?
Thanks for having me over, Jennifer. I'm Dr. Rajarajan Sivaraj. I'm the Director for Standards and Architecture at Mavenir. I've been with the company since August 2020. Prior to joining Mavenir, I was a Senior Inventive Scientist with AT&T Labs Research. My area of expertise lies in 4G and 5G, cellular RAN systems design, and cross-layer networking. I've also had work experiences with Microsoft Research, Intel Labs, Broadcom, NEC Labs America, and Princeton, New Jersey. Prior to my industry experience, I finished my PhD in computer science from the University of California at Davis in December 2016. I'm currently based out of Plano in Texas.
So 5G is at the verge of hitting the market in full commercial capacity. So what do you foresee as some of the challenges in implementing the infrastructure for 5G?
So 5G can be deployed in two frequency bands. One is what we call as sub-6 frequencies, which is 6 gigahertz and less. And the other is millimeter wave frequencies, which is basically more higher frequencies like 39 gigahertz, 50 gigahertz, and so on. Now, when you look at millimeter wave frequencies typically, right, the bandwidth of one cell itself will be in the order of hundreds of megahertz. Typically 100 megahertz would be the bandwidth of one cell in the millimeter wave, right? And then basically, also in terms of the antenna transmission. So you basically have this multi-antenna transmission. In LTE days, we spoke about 2 cross 2, 2 antennae at the transmitter, 2 antennae at the receiver, and then 4 cross 4, and then we spoke about 8 cross 8. Now moving to 5G onwards, we speak about something called massive MIMO, which is called massive input, massive output, which basically means you'll have 32 cross 32, 32 antennae at the transmitter, 32 at the receiver, 64 cross 64. So you have multiple dimensions in that case. You have multiple transmit antennae and multiple receive antennae. The reason why you have these transmit and receive antennae is so that in the same frequency time resource, you can transmit to multiple mobile devices, right, while minimizing the interference. So when you have to, and the reason why you want to do it for 64 cross 64 or 32 cross 32 is because at the same frequency and time, you want to transmit to as many users as possible, to maximum number of users, right? So this basically requires a lot of interference mitigation, cancellation techniques. And then the reason when you go to millimeter wave bands onwards, which is 39 gigahertz, 39.4, 50 gigahertz and beyond, right? You have a massive bandwidth, but millimeter wave basically has a very short range of communication. When you have a higher frequency, your path loss is also high, so the range of coverage is basically short, right? So how can you efficiently make use of the spectrum of the coverage with limited coverage, but with massive bandwidths? And how would you be able to provision more low latency services, more high bandwidth type of services? So these are some real challenges what you have. So when you have a massive deployment of antennae, what you call as massive MIMO or massive multi-antenna transmission. So trying to make sure that the interference is limited, the interference is mitigated, and you basically have higher bandwidths in higher frequency bands such as millimeter wave, right? But with lower coverage. How can you efficiently plan and deploy millimeter wave cells, right? With massive, antennae, with massive MIMO features, so that you would be able to efficiently use the coverage and capacity. So this is, these are all challenges what you have. Now moving to the lower frequency bands, right? Typically bandwidths in 700 megahertz, 850 megahertz, 1900 megahertz, and so on. Now these are also bandwidths that are basically used for LTE. Some of these bands have also been used for LTE. So how can you basically do dynamic spectrum sharing between 5G and LTE so that you can basically foster coexistence between these multiple radio techniques? Now these are all some important challenges in 5G, in deploying 5G. Right, and 5G is more about densification of the network. So, how many cells, do we deploy? And we have to deploy a densified network of cells. So, how can we make sure that the frequency is efficiently reused between the cells, that the transmission across cells do not really interfere with each other, or the interference is mitigated? How can we basically provision very high bandwidths at the same time, not really starving some users of resources, especially those users who are present at the edge of the cell, right? Just because we are trying to serve a user who's in a better network condition, with higher performance, doesn't mean that we'll have to end up starving resources for the users who are present at the cell edges. So these are all some deployment challenges that we have towards optimally deploying 5G, and these are all some of the real-world challenges that we have in deploying 5G.
So obviously all this is very new, and there are a lot of engineers who want to start working in 5G, right? So what do you think is the associated skill gap in this field?
So up until 4G onwards, we basically required more unidimensional skills. For example, we expected an employee to have skills just in the telecommunications side. So we required systems engineers who had adequate expertise on the telecommunications, on systems design, on the protocol stack. And then we basically didn't require these people to have skills in other domains such as machine learning, in cloud, in microservices, etc. But 5G is basically an interesting, it's basically an interesting game shift, because you're expecting people to have expertise not just in communication design, not just in wireless communications, but also in these areas of computer science optimization, algorithms, analytics, machine learning, data science and data engineering, as well as cloud-native microservices design expertise. So we expect people from across the spectrum who have expertise in more than one area, communications, computer science, algorithms, to come together, because that is what is required towards provisioning these myriad applications that we reviewed. With just unidimensional skills and without expertise on other areas like machine learning, we wouldn't be able to come up with solutions that cater to the needs of these applications. For example, 5G focuses on three key areas. Number one is bandwidth-intensive applications that require extremely high speed. Number two, ultra-low latency, which typically expects round-trip times of less than 10 milliseconds, less than 5 milliseconds, and sometimes units of milliseconds. And then extremely high reliability. That is, even a data loss in the order of 10 to the negative 5 is not tolerated. So some of these applications require, reliability in the order of 1 minus 10 to the negative 5 to 1 minus 10 to the negative 7. So this requires extremely high reliability. These require extremely high reliability to be met. So in order to cater to these requirements, it is expected that an employee has expertise in multiple areas. Communication design, how he can use computer science algorithms towards solving these communication problems, and how can he scale up his design, how can he use more cloud native, innovative microservices, and services-based architecture, leveraging the power of cloud computing, analytics, towards designing systems that offer these applications through 5G technology. And the skill gap that we basically have is that we don't really find many people who are at the intersection of these multiple skills. So that is one of the reasons why we need to equip a person who's having probably 5 to 10 years experience just in the wireless communication and wireless protocols. We need him to be equipped with computer science optimization techniques, with machine learning, with data analytics, and also we require people, who are systems engineer in cellular networks to also be equipped with cloud native and microservices design, cloud native software, cloud computing, and a bunch of cloud orchestration tools. So that's one of the reasons that we've come up with this course that helps meet these skill gaps and gives a more interdisciplinary dimension to this course that touches upon these multiple aspects of technology.
So in terms of university education, right, where do you think the students are losing out, especially for people who are pursuing masters and PhD?
Yeah, so Jennifer, the people would miss out on the following if they are not able to gain skills that we're offering through the course. People would lose out on the following. Number one, lack of understanding of how a 5G or a 4G system works. Now, 5G or 4G system or communication system, for example, it is not a very simple or straightforward design. There are a lot of inherent protocols. There are a lot of intricacies that are handled in the way we design a system because of the number of concepts that we'll have to support, the number of features we'll have to support in a cellular mobile telecommunication network. So a lack of ground truth understanding of how a 4G or a 5G or a beyond 5G cellular system would work. Second, lack of exposure to analytics and machine learning techniques in the domain of telecommunications. Like, how can people apply machine learning techniques to solve telecommunication problems? That is something that people would lose out on. Because in this stream, we are not offering a standalone machine learning course, right? We are offering a course that would enable people leverage machine learning skills on solving practical telecommunication problems. So that is something that they would lose out on. Lack of exposure to cloud native technologies and cloud native design principles, because gone are the days where people used to rely on monolithic technologies. Now moving forward, even communication systems like 5G are going to leverage cloud native design principles, cloud deployments, harnessing the power of cloud computing, cloud storage, cloud native analytics. So these are the skills that people would lose out on as a result of not learning the skills that we're offering through the course, because these form the fundamental principles of how we are going to design telecommunication systems moving forward from 5G onwards.
So how do you think EdTech can help in filling up this gap that you see?
Yeah, so basically, as we reviewed previously, the course will have 3 streams. As I said, the first stream is 5G, so we'll basically spend at least about 6 to 12 weeks reviewing 5G concepts, 5G protocol stack layers, 5G analytics, and also 4G, by the way, because 4G is still in deployment and it's going to be there for the next at least 7 to 10 years. LTE is here to stay for the foreseeable future. So 4G, 5G, as well as beyond 5G concepts. So that is basically going to take about 6 to 12 weeks, and then we will have another 6 to 12 weeks that's focused purely on analytics and machine learning, and then the final few weeks will basically focus on cloud concepts. And then the students are expected to do a project, or the enrolled engineers are expected to do a project in each stream that we are offering. For example, the first stream, the enrolled engineers and students would do a project involving the network simulator NS3, as well as mobile insight packet capture tool. And then when we go into the analytics and machine learning stream, the enrolled engineers would basically have to do projects using Keras, TensorFlow, sklearn, Python libraries, PyTorch, etc. And then when they basically move towards the third stream, which is cloud native microservices design, they'll be able to play around with more virtualized software, with more cloud platforms, with orchestration tools. And all these will basically culminate in projects where they would be able to apply skills at the intersection of 5G communications, machine learning, as well as cloud. So this is how we are planning to structure the course, and basically whatever skills that would have resulted, whatever skills the engineer would learn in the 6 months course is something that he would have otherwise required or taken 3 to 4 years to learn all the broad set of skills that we are offering through this course. So that's how we are structuring this course into 3 streams, and then there's a course project in each stream, and then there is a fluid transition of flow across these 3 streams. Now these 3 are not independent streams; they are well connected to each other, because we are going to review these 3 streams with 5G and communication design as the connecting principle. So even as we go into the concepts of machine learning as well as cloud, it will all be covered from a 5G and from a cellular mobile communications perspective. So it's not like we are going to learn 3 different streams in an independent fashion. These are all going to be completely connected, and the transition is going to be smooth across these 3 streams.
And also, what are the job opportunities that EdTech can help in filling in?
An engineer who is gaining these skills can very reasonably expect, can very fairly expect a boost in his pay scale at least by $30,000 to $50,000. Now that's a very conservative estimate, because all the interviews, and not just the interviews, and also the job opportunities and the job responsibilities that they will have to take up, even when they go to more senior level positions, are going to be centered on the basics that we are handling in this course, are going to be centered on the concepts that we are handling in this course. So the target audience, as I said, are engineers as well as master's PhD students. Now, upon taking up this course, certainly an engineer would raise to principal level. So the expected promotion or the expected career position that engineers would be availing as a result of taking up this course would be something like principal member of technical staff, principal scientist, principal technical architect, principal engineer, lead operations engineer, etc. So once they take up this course, certainly there would be an elevation or boost in their career that would result them in acquiring more principal positions and lead positions in their organization, as opposed to staying at a more junior or at a relatively senior level. They would advance to more principal level in their job opportunities, which would definitely result in a pay scale increase by a minimum of $30,000 to an average of around $50,000.
What are some of the top consumer-facing industries that will have the maximum impact due to implementing 5G? And can you tell us a little bit about the prominent use cases, just some of them?
So it's a good question, Jennifer. So the consumer-facing industries that are going to be, that are basically going to be impacted by 5G, or that would be able to harness 5G and the use cases that they'll be building, include a whole new suite of them. For example, gaming industries, because moving forward, we are basically seeing more AR or VR-driven games, not just traditional video games, but more, VR-based video games and AR-based video games. So that is definitely, a billion-dollar industry, which would be significantly impacted in a positive sense as a result of the boom that we see in 5G. Because more of AR cloud streaming games, which by itself is a trillion-dollar industry, would come into business, would come into market, and they would offer unprecedented customer experience that we've never even experienced before. That is one industry. The second vertical is by itself drones, because moving forward, right, a lot of countries' military forces, countries' government forces, basically require real-time video streaming from drones, especially when they are doing disaster management, especially for the nation's defense or for security of a country, where they basically require to have a live streaming from 360 degrees, with high quality, so that they would be able to detect suspicious activities in key areas, or while managing disasters, while recovering from catastrophic events. So in such circumstances, drone is a big industry that would get positively impacted by the boom in the 5G technology. And then, the movie industry, because OTT has become the talk of the town these days. People are adopting to more OTT-based video streaming or movie streaming from their homes, as opposed to going to cinema halls or theater houses. So now what people really want is a visual experience. Because even as we are looking for, even as people want to consume more OTT content, they're looking at more 4K or at least, very high quality video streaming, for the movies, to look at the stars that they love, to look at the heroes that they adore, right? So this is another industry that would get positively impacted by 5G.
And what about telemedicine? It looks like 5G can make a huge difference in this space.
Absolutely. So with telemedicine is a game changer, and telemedicine industry is going to be positively, the healthcare sector is getting positively impacted as a result of 5G. The reason how this could happen is because you can have a dedicated infrastructure deployment in 5G. It's basically called the user plane function, and it's basically called slicing, right? Which can be used purely to handle healthcare, purely to treat patients, from a doctor present in a remote location. Now, when you basically have such dedicated infrastructure through slicing, through user plane functions, right, through deployments, you basically want to allocate dedicated resources for telemedicine. And because a doctor, there are some limitations in doctor being at physical locations to treat each and every patient. For example, if a doctor has profound expertise in a certain field of medicine, he probably may be employed with a single company or with a single firm. So if he has to treat multiple patients that are basically at multiple locations for the hospital chain, then it is very difficult for him to keep traveling frequently. A lot of time gets wasted when he has to attend on a patient immediately. So in such cases, remote telemedicine and remote telesurgery are use cases that we are exploring in 5G. Now, with the 5G systems design, it is certainly possible to have remote telesurgery treatments, because 5G focuses on ultra high reliability and low latency. When you basically have a physical robot on site that is operating on a patient, but when it is controlled by a doctor at a remote location, we need to make sure that the doctor's actions are getting transmitted to the robot at very low latency, without experiencing delays, which 5G can actually offer because of virtualized deployments, because of slicing, and because of dedicated user plane functions, and because of the wireless design, the wireless systems design, which is basically optimized towards handling these lower latency services. And also, apart from low latency, ultra high reliability is an example. For example, if a doctor is at a remote location and if the robot is performing on the patient, there shouldn't be data loss at all, or the data loss should be very, very, very minimal, right? That is something which, again, 5G can guarantee, because through concepts of slicing and through concepts of quality of service that we have in 5G, and with the concepts of the protocol design in 5G, when solutions are optimized, when optimal solutions are implemented effectively, then we would be able to meet the service demands of remote telemedicine and remote telesurgery. And thus, you basically can have a doctor present in a remote location, but can treat patients at different chains in the same hospital, without really accounting for travel costs and travel time. So definitely through the concepts that we're covering in the course, such as especially slicing, especially 5G slicing and 5G systems design, the engineer would gain adequate expertise that would help him come up with solutions that would help him analyze how 5G can meet the service demands of telesurgery, remote telemedicine, etc.
So do you see any big change in the B2B market with 5G?
So the B2B industries are looking at more private 5G. They're looking at more private deployment of 5G networks such that the infrastructure is not shared by other cellular networks. So the infrastructure is not shared by public network. This is basically used for more latency critical operations like, like remote factory automation and stuff where they need to have a dedicated infrastructure that doesn't really share the infrastructure or the spectrum resources with other cellular networks. So how can you offer guaranteed quality of service through private 5G? Because when an enterprise is paying for private 5G, he is certainly expecting guarantees out of that infrastructure that he is buying. It can no longer be a best effort service. It should be a guaranteed service. So these skills that an engineer would learn in this course would help him come up with solutions that would meet the design requirements of these newer forms of deployment, such as private 5G networks. Private 5G networks are also being used by a lot of automobile companies because they basically want to test how their self-driving cars can be controlled using 5G networks. For example, if there is a driverless car on the road and if it has to be controlled with ultra-low latency in real time, right? Then in such cases, automobile companies are looking at, are basically looking at 5G optimizations. And for doing remote factory automation in their companies, they are also looking increasingly at private 5G networks that basically would avail them to use dedicated infrastructure and network for automating their car production factory, or for their automobile production factory. So that's another thing which they're looking into. And all these require meeting these demands on latency, reliability, etc. So again, the skills that an engineer would gain by taking this course would help him provide optimal, solutions through private 5G networks that is getting increasingly adopted by the industry.
And lastly, I want to know what happens to the tech employees after the rollout of 5G, because obviously we know that there's going to be a cascading effect that's going to affect all of these employees who are currently non-engineers working in this particular stream. So how do you think they can upskill themselves and to stay relevant in this industry, obviously?
So basically, 5G is a technical concept, as you said. It is a concept that is based out of wireless telecommunications. So someone who is an expert in wireless telecommunications would have the essential fundamentals that would help him design 5G systems. Now, as far as non-communication engineers are concerned, right? Now, 5G is also about a whole new suite of applications, as I was saying previously, right? Like for example, a lot of automation can be done as a result of the deployment that we can provision through 5G systems. Now, as far as automation is concerned, right? Automation industry is something which is facing a big uphill because of the number of jobs that are getting automated. Now, automation requires infrastructure, right? It requires ubiquitous connectivity. So with the densified deployment of 5G systems, with 5G we're expecting a more densification of the network. We expect a more ubiquitous deployment of the network. So there'll be anytime, anywhere connectivity. There will basically be Internet of Things, for example, wearables, for example, right? IoT devices, which basically are not really bandwidth intensive data, but they send a lot of data because they basically get a lot of information about patients who are wearing these wearables and send them to a centralized cloud so that the patients can get more customized treatment for their health problems, right? So all of this requires a ubiquitous connectivity and a pervasive connectivity that is available, for all the users irrespective of their location, sometimes called anytime, anywhere connectivity. Now, with 5G, because of the pervasive deployment, there will be more network-enabled applications, network-enabled systems. So even if non-communication engineers have to contribute to the space, or if they want to leverage 5G, they can basically leverage the anytime, anywhere connectivity that 5G provides. For example, when we have smart TVs at home these days, we mostly connect the smart TVs to our Wi-Fis and then start streaming content. Now, with 5G onwards, you'll basically see a lot of mobile TVs connecting to mobile broadband, right? TVs that were basically connected to the mobile network. So 5G is in some sense going to probably replace all of the traditional networks that we've seen, because they can cater to the different types of demands that are expected out of mobile applications. And significantly, people who want to develop their software, more network or internet-enabled software, they could harness the power of 5G through the anytime, anywhere connectivity feature that 5G can offer. So a lot of these automation jobs, applications, app developers who don't know anything about 5G design concepts, but who basically want to build internet applications, they can basically use or they can leverage the capability that 5G is offering. So more billing systems, automation jobs, healthcare services, government services, digital services. For example, the Indian government focuses quite a lot on, this project called Digital India that focuses on, digitizing a lot of information and using a lot of cloud capabilities. Likewise as our governments in Europe and in the US as well. So all of these governments, when they have to roll out more digitized services to their citizens, they could harness this ubiquitous connectivity that 5G is giving. Instead of worrying about the infrastructure, they'll have to deploy in order to facilitate these services. So that's how non-communication sectors would also be benefited by 5G.
All right, Mr. Rajarajan, thank you so much for joining us in today's episode. We wish you all the best in all your future endeavors.
Thank you, Jennifer. It's a pleasure and honor.